Good morning, my name is Alessandro and I'm a useware analyst and I'm researching Neanderthals and modern humans adhesives at Leiden University and Delft University of Technology. This presentation will focus on different useware traces that develop on South African rocks and European ones. As we know, several factors influence the formation of wear traces on a tool, including the tool's raw material. During prehistory, a wide range of rocks have been used for tools manufacturing by hunter-gatherers. However, in the last decades, most of the functional studies have focused on flint tools. To overcome this, we carried out an experiment aimed to understand the development of useware traces on non-flint African rocks, resulting from different contact materials and actions, and to assess comparability with European flint. To answer our research questions, we conducted a field experiment in which we use a range of tools on a variety of materials. We focused on 4 different variables that affect the formation of useware: raw material, contact material, motion, and time. Hafted hand scrapers and handheld flakes made from chert, dolerite and quartz were used on fresh hide, bone and reed with longitudinal and transverse motions for 60 minutes. To understand wear traces development, pictures of certain spots of the active edge were photographed before and after the use. At the end of the experiment, tools were analyzed with low power and high power approach. A comparative analysis between experimental traces on flint and non-flint tools was undertaken to spotlight common traits or differences in the useware resulting from the work of different materials. Because of the time constraint, today I'm going to discuss only traces resulting from the hide scraping activity. Scraping hide with a flint tool resulted in light to moderate edge rounding and an invasive polish with rough and greasy texture. Polish developed in a characteristic bend and follows exactly the shape of the edge. The same holds for chert. Hide scraping produces a light rounding and a lightly developed polish distributed in a band along the edge with a rough and greasy texture. On the dolerite scraper, a moderate edge rounding and an invasive polish formed after the scraping activity. Polish distribution is not uniform along the used edge because of the uneven microtopography of this rock. Polish developed in isolated patches with a granular texture and a flat topography. The quartz scraper displays a moderate edge rounding. Polish developed in isolated spots and exhibits a rough and greasy texture. Because of the hardness of quartz, the polish developed more slowly compared to the others' experiments. As briefly pointed out with the previous example, the useware traces that we observe on these African rocks share similarities with European flint. Edge rounding developed on all the tools, as well as polish. However, polish attributes slightly vary in between different lithic raw materials, especially in terms of distribution and texture. Traces on chert tools are overall the most comparable with flint, while dolerite and quartz also exhibit specific traits. To conclude, the preliminary analysis of the results from this experiment highlighted a certain degree of overlapping between traces on flint and non-flint rocks. The data will allow us to better interpret useware traces on different lithic resources commonly exploited by South African hunter-gatherers group in the past. In addition, the experiment will also serve as a small reference collection for the study of non-flint tools from the archaeological site of Steenbokfontein Cave in the Western Cape province of South Africa. Thank you very much for your attention and thanks to all the EXARC team. For further information about our project, do not hesitate to contact me.